So we meet again. This is Mr. Minnick again. This is part 2 of this Algebra 2A Chapter 5 introduction, this worksheet. And now we're looking at the third page. It says, determine whether each polynomial is in standard form. Now, let's go back for a minute. Standard form. Descending order by degree. Descending order by degree. Degree is the largest exponent found on a term. So, descending order. Well, if we look at the first function, the term with the biggest exponent is 4x squared, and it's not first. So, I think it's pretty clear, I hope it's pretty clear, that this one's not in standard form. So, on this one, y1 would equal 4x squared. We have to put that term first. And then the term with the next highest exponent next, so plus 3x, and then the minus 5 on the end. Okay. The directions go on to say if it's not, then write it in standard form. So we did that. Identify a sub n. So let's go back. A sub n. A sub n is the constant term all the way on the end. It's the one who has an exponent of 0, even though you really don't see it. So we're looking for the constant. So the constant in this particular term is -5. Okay. Now it says graph the function and find the y-intercept. So it's a good thing I have my graphing calculator at the ready. So here we go. Y equals 3x plus 4x squared. The function doesn't have to be in standard form to put it in the graphing calculator, but you probably already knew that. So to find the y-intercept, I calculate a value whenever whenever x is 0, my y-intercept is -5, or the point, I should be a little more clear, 0, -5. Okay. y2, the first term has the highest exponent, but the next one doesn't have the next highest exponent. So y2, we should have 8x to the 7th, it looks like, and then minus 2x cubed plus 3x plus 4. Okay, so that's y2 in standard form. 8x to the 7th minus 2x cubed plus 3x plus 4. Okay, so let's go ahead and graph that function. And let me get my window back to a standard window, a 10 by 10 here. So let me graph y equals 8x to the 7th minus 2x cubed. If you didn't know, your calculator actually has a cubing feature on the TI 84 and 3. If you go math, it's option 3. It's a little shortcut that Mrs. Carlson actually showed me. Plus 3x plus 4. So we graph this, and let's look for the y-intercept. It looks to be 4. Let's calculate a value when x is 0. Wow. Okay, so the y-intercept on this one is 0, 4. And a sub n, the constant term, is also 4. So you probably realize by now what's going on. y3 is already in standard form. A sub n is 4. And if we graph that, you probably know just from your study of lines that the y-intercept is 0, 4. Okay? So let's think about this. A sub n, that's the constant. And the y-intercept, they're in effect the same thing. Just keep in mind, usually when we refer to a y-intercept, we talk about its coordinates since it's a point. Okay. When we talk about the constant, it's just a term, so it's just a number. Okay. So the group that had this third page, then you had this table to complete. Some of you might have tried the 5.1 homework already. If you did, it certainly would help with this table. What I'd like to do in this table is go to the one where the degree is 1. It's linear, okay? That's filled in for us. When the degree is 2, it's quadratic. That's filled in. Wow. Well, when it's quintic, if you study Spanish or any Latin language, that might help you. Quintic should not be confused with cubic or quartic. Quintic, quint. Not to be confused with the quintessential, but quint means 5 in Latin languages, so it's a degree 5 is quintic. Cubic, you've probably seen if you cube something, you raise it to the exponent 3, so cubic is degree 3. Quartic, it's hard to say. Some people say quartic, some people say quartic, some people say quartic. Either way, the degree is 4 there. Okay. Now, some people want there to be, if you go to degree 6, if the degree is 6, okay? Some people want to make this one up. It doesn't exist, okay? They want it to be sextic, okay? Well, degree 6 is not sextic, okay? Degree 6 is not sextic. If it were, then degree 7 would have to be septic, and that would stink. So for that reason, we don't have anything called septic. It's just 7th degree, okay? 7th degree. Nth degree and 6 plus. Let's see. So it seems like anything higher than 5, and that's where the cutoff point is. Anything higher than 5, remember the degree has to be a whole number. So anything higher than 5 is just called an nth degree, okay? So the degree for an nth degree would be n. So 6 plus, 6 or more, is an nth degree, okay? So if the degree is 6, we would just say it's a 6th degree polynomial. It's not sextic, okay? And 7th isn't septic. So, all right. So I think there's one more table here, I think. This last table is where we name based on how many terms. Oh, yeah, what if the degree is 0? What if the degree is 0? What if we had a polynomial p of x equals 7? Okay, what you have to realize is that there really is an x term there, and the only way for x to be there and for it to go away is if its exponent is 0. That's 7x to the 0, okay? Which means that it's 7 times 1, which means that it's just 7. And 7's a number, and earlier we referred to the number as a constant, okay? So when the degree is 0, it's a constant. If there's just a constant, the degree of the polynomial is 0, okay? One-term polynomial is called a monomial. Sometimes I pronounce them as monomials, not as if you're eating, but just, I don't know. So if we have a binomial, then there are 2 terms. If there are 3 terms, it's a trinomial. And in the event that there's more than 3 terms, you can't have 2.5 terms or 3.5 terms, but if there's more than 3 terms, 4 or more terms, we just refer to it as a polynomial, okay? A polynomial. In the book, we'll take it farther and say it's a polynomial with n terms, a polynomial with 4 terms, a polynomial with 5 terms, okay? So that's page 3. I hope that you're doing all right with this stuff. The pages so far. Hopefully that one, everyone, or the group that had that got through it. This 4th page, if you had a chance to look at it, you probably looked at it and said, I don't get it. So let's take a look at this. Finite differences. Finite means it ends or stops. Differences means subtract in mathematics. So what we're doing is subtracting consecutive y values for evenly spaced x values of a polynomial function. There's all kinds of theorems about polynomials, and the one that we're looking at now on this page says an nth order finite difference. If the nth order finite differences of a polynomial are constant, then the polynomial is of degree n. Nth order finite differences of a polynomial function of degree n are constant, okay? So it's kind of a weird theorem, kind of odd, and we're going to take a look at it right now. So if you look at this triangular array of things, it's kind of daunting, kind of intimidating. On the left edge, we've got p of 0. That just means the y value when x is 0 is 1. Okay? The y value when x is 1 is 1. So in other words, this function would go through the point 0, 1, and then 1, 1, which seems kind of weird. It seems like a flat line or a horizontal line at first. But then when x is 2, the y value is 23. So notice evenly spaced x values. So the x values that we're looking at, This is x, 0 and 1 and 2 and 3 and 4 and 5 and 6 and so on, okay? And then the y values are 1 and 23 and 139 and 469 and 1181 and 2491. And I don't know if it goes any further than that. No, that's it. Okay. So the finite differences, we take the y values. We take the y values and we subtract them. And the key here is subtracting consistently. It doesn't matter if you start with the second one and subtract the second one from the first one or the first one from the second one. What does matter is that you're consistent about it. You are consistent about it. So if we look at 1 and we subtract from that one, this one take away 1 is where that 0 comes from. Okay? So if you missed this, 1 minus 1 equals this 0 right here. Okay? Following suit then, let's go down to the next pairing. So now we start with this one and we subtract from it this one. All right? So again, 1 minus 23 is where the negative 22 comes from. Okay? Consistency. Be consistent. Okay? Don't go 139, then all of a sudden minus 23. Start with the 23 and subtract from it 139. Okay? So you got to be consistent when you subtract. So 23 minus 139, that's where the negative 116 comes from. Okay? So on down the list. So this column here is called the first order differences because all we did was found the differences of the first the initial y values, and that's called the first order differences. If those differences were constant or were the same, by the theorem we'd have a linear function. But they're not, so we got to keep going. Okay. So what we do next then, same idea, subtract. So now we start with 22 and take away from 22, 94. Okay. So 22 minus 94 is where the negative 72 comes from. And 94, take away 214 is where the negative 120 comes from. Okay. So let me go ahead and just fill in the remainder of this table here. At the bottom of this first order differences, we should add negative 1310. Underneath the 214, we're going to get 382. And then underneath the 382, we're going to get 598. Underneath the negative 120, we get negative 168. Underneath the negative 168, we get negative 216. Underneath the 48, we get 48. And underneath the 48, we get 48. So that's what you should have had in the rest of each of those tables. So what happened here, the first order differences were not constant. First order differences were not constant. If they were, we would have had a linear function. Okay? So the second order differences, 22, 94, 214, those aren't constant either. So the degree of the function is not quadratic. Third order differences. The third order differences are negative 72, negative 120, negative 168, negative 216. Clearly that's not constant. We had to go all the way out to the fourth order differences. Those were constant. So the degree of the polynomial is 4 since its fourth order differences are constant. There will be exercises like that in the Math Excel homework. Actually, I think there's just one. You will encounter those on an upcoming quiz or chapter test. So hopefully this whole activity has been enriching. Hopefully you learned some new things along the way. Maybe it solidified your understanding of that you already had of polynomials. So that's it. It's been real. It's been fun. I'll see you the next time. Have a great day.